So this video, I'm going to wrap up some things that we talked about in the last video. So we talked about finite extensions, and I was going to say how this was a tool to talk about addition and subtraction of algebraic elements. So addition and multiplication, I should say, and multiplication of algebraic numbers. Okay. And so the goal is, well, I'll just state it. So basically, we want to be able to prove that things like square root of 2 plus the square root of 3 are algebraic. So if you take two algebraic things and you add them together or multiply them together, they're going to still be algebraic. So let me just state this formally. So lemma is the following. So let L over F be an extension of fields. And then if alpha and beta in L are algebraic, if they're algebraic over F, then so are alpha times beta and alpha plus beta. So as a consequence of this is that so things like square root of 2 plus the square root of 3 satisfies some polynomial equation with coefficients in Q. Okay, so let me give the proof of this. The proof isn't so bad. So let's do the proof. Oh, I need to let me pause for 1 second. I need to add pages to this notebook. All right, the pages have been added, and now I can turn the page. And so here's the proof. So the idea is that the field, so let alpha and beta and L be algebraic. So the field F alpha beta, so if I just adjoin these two elements, this contains F, is a finite extension of degree at most, well, F alpha F beta of F. And this is because since alpha I beta j, these generate or let's say span F alpha beta as an F vector space. So there might be smaller relations, but we certainly have, so there might be more relations among these, but they certainly span it. So this means, so this implies it is finite dimensional, a finite extension. So by it, I mean this field here. It is a finite extension, and hence and every element, as we saw before, and every element of a finite extension of F is algebraic over F. That was one of the first things we proved. Okay. So that's the proof of this statement. Okay, so in particular, so let me just maybe just say this, since alpha times beta is in F alpha beta, and alpha plus beta, so this is also in F alpha beta. So this implies they're both algebraic. Both are algebraic over F. Okay, and that's all there is to it. Okay, so now let's do an example.